Section 4.5, Isosceles and Equilateral Triangles. The congruent sides of an isosceles triangle are its legs. The two congruent sides form the vertex angle. The third side of the triangle is referred to as the base. The other two angles of the triangle are the base angles. So we've got our two congruent legs, and then our base, and then we have our vertex angle at the top, and then our base angles. Theorem 4.3, the isosceles triangle theorem, states that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So in this case, if we know CA is congruent to CB, we can say angle A and angle B are congruent as well. Theorem 4.4, the converse of the isosceles triangle theorem, states that if you know that the two base angles are congruent, then you know the sides opposite them are also congruent. So here we are given that xy is congruent to xz and xb bisects angle yxz. And we're asked to prove that angle y and angle z are congruent, but we're not allowed to use theorem 4.3 or 4.4 because that's what we're trying to prove. We're trying to prove the isosceles triangle theorems. So to start this proof, we'll start off by restating our given. Since we know that xb bisects angle yxb or yxz, we're going to use that keyword bisects, and we're going to see what really happens. Well, if xb is bisecting angle yxz, we know that angles 1 and 2 should be congruent because that's what the angle bisector does. So in our second step, we'll talk about angle 1 being congruent to angle 2 by definition of angle bisector. At this point, we have side, angle, and maybe we need another side. So let's say that xb is congruent to itself by the reflexive property. Now we have enough to show that triangle yxb is congruent to triangle zxb by side, angle, side. So triangle yxb is congruent to triangle ZXB by side, angle, side congruence. Now that I know that the two triangles are congruent, I can show that angle Y is congruent to angle Z because they are corresponding parts of congruent triangles. So my last step is going to be angle Y is congruent to angle Z by CPCT. In this example, the question is asking, is segment AB congruent to CB? And explain. So we're looking at AB, which is this segment here, and they want to know if that's congruent to CB. Well, if we focus in on these two angles here, these are the base angles to this much larger triangle. So we can see that since angle A is congruent to angle C, AB should also be congruent to CB by the converse to the isosceles triangles theorem. Then question B states, is angle A congruent to angle DAE or DEA? So let's go back and look. They want to know, is angle A congruent to angle DEA? Well, the opposite of what we just saw is in play here. Since we know that DA is congruent to segment DE, then angle A should be congruent to angle DEA by the isosceles triangle theorem. Here it says, is angle WVS congruent to angle S? Is TR congruent to TS? Explain. Well, let's see. WVS congruent to angle S. So the first part of this is a yes. And is TR congruent to TS, which is also a yes. And we know this all because WV is congruent to WS, therefore that angle S and angle V are congruent. And if angle S is congruent to angle V, which is already congruent to angle R, those three angles are actually all congruent, which means that R and S being congruent makes TS congruent to TR. And so we can say yes, all because angle S is congruent to angle V, since WV is congruent to WS. Part B says, can you conclude that triangle RUV is isosceles? Well, let's go back and look at RUV. RUV. Well, we only know one angle, and we don't know anything else about the triangle, so no, we can't. There's not enough information. All right, theorem 4.5. If a line bisects the vertex angle of an isosceles triangle, then the line is also a perpendicular bisector of the base. So ultimately, if you have a line coming down the middle of your isosceles triangle that's breaking the top vertex angle into two equal angles, it is also going to be perpendicular to the base and bisect the base. All right, so here we're asked to solve for the value of x. So in A, if we notice carefully, we've got congruent segments here and here, the congruent markers. So we have congruent sides, which means that angle D and F should also be congruent because they're base angles. So for this problem, I'm going to take x plus 30 set equal to 180. I'll subtract 30, I get 2x equals 150. Divide by 2, x should be 75. Question B, I've got x here, I've got 5, I've got y, plus 3, and I've got 42. And the 42 goes to this guy here in this corner. But what's most important is I notice that I have a bisected angle here by NO. And this is a vertex angle of an isosceles triangle. So if this is the line bisecting that angle, we know that it's also going to be perpendicular to the base, and it's going to bisect the base itself. So to solve for y, we're going to take 5 equals y plus 3. We'll subtract 3 naturally, and we get y equals 2. To find x, I should recognize here that this angle is 42, but this angle here is also 42. They're base angles. So I can take 42 plus 90 plus x and set equal to 180. So I've got 132 plus x equals 180. I'll subtract 132, and I get x to equal 48. So here we have corollaries. A corollary is a theorem that can be proved easily using another theorem. So corollary to theorem 4.3, if a triangle is equilateral, then the triangle is equiangular. So basically, if your triangle, all of its sides are the same, all of its angles should be the same as well. And then the opposite of that is corollary to theorem 4.4. So if all of your angles are the same, then all of your sides are the same. So if a triangle is equilateral, it's also equiangular. So here we have a picture of a triangle that is clearly equilateral since all the sides are the same, which means each of the angles within the triangle should be the same as well. So we have a couple of ways of setting this up. Well, we know if all of the angles in this case are 4x, we could merely just take 4x plus 4x plus 4x equals 180. So in this case, we're going to take 12x equals 180. We'll divide by 12, and we get x to equal 15. Okay, and so now that we know what x is, we can plug it back in here, and we get 60 degrees. This angle and the y should make a linear pair, so to find y, we're going to take 180 minus 60, and we get y to equal 120. In the second problem, we've got markers indicating a lot of things. Right now we've got isosceles. We've got n here. We know that this is also n because these are the base angles of this isosceles triangle. We've got m. This should be m as well. And so now we're just trying to figure out what we have. Well, to find n, it's pretty straightforward. We'll take n plus 90 equals 180. So at this point, we've got 2n plus 90 equals 180. Divide by 90, you get 2n equals 90, and n should equal 45. So ultimately what happens is this is 45, and it's got the marker. This angle here is also 45. So to find m, we do something very similar. We're going to take m plus 45 equals 180. So that gives us 2m plus 45 equals 180. So we've got 135 when we subtract the 45 from it, or from 180, equals 2m. Therefore, m equals 67.5 degrees. Question 3, we've got essentially what looks to be two overlapping triangles. And so let's just look at and see what we can figure out. Well, for this triangle here, we know if this angle is y, this angle down here is y because of the isosceles triangle theorem. They're the base angles. If this angle here is 37, this angle here is also 37. All right, so this is what we have. But before we start too far into this, we should notice that if we were to isolate just these two outer triangles here, notice here that we have x and x here, which makes those angles the same. We have a side here and a side here that are equal, and then we could use vertical angles here if we wanted to. So these two triangles are actually congruent. So finding angle y is really easy. These two angles would correspond. So y is just automatically 37. And so now if we go back to our picture, we can start to make sense of where some of these things go. So down here, we've got 37 as well. We know this guy is 37. And so ultimately to find x, we can now look at just this triangle here. Well, think about all the measurements we have. We've got 37 plus another 37 plus one more 37. And the only thing missing would be the plus x, and then we could set that triangle equal to 180. So here we've got 111 plus x equals 180. We'll subtract 111 and we get x to equal 69 degrees. So we've got y to be 37 and x is 69 degrees. Last but not least here, we've got two congruent base angles, which means the sides of this isosceles triangle are congruent. So we're merely going to set the two equal to each other and solve. So we'll subtract 3x, we get 4x minus 10 equals 6. We'll add 10, we get 4x equals 16. And then we'll divide by 4, so x equals 4.